Good afternoon, sir.
Yeah, good evening. How are you? Am I audible?
Your voice is not clear, sir.
Voice. Yeah, just a minute. Is it clear now?
Yes, sir.
So how are you?
I am fine, sir.
So, what are you doing?
I am doing BTech, sir.
Okay, which year?
Third year student.
From where?
I am from Bihar.
Where? Which college?
I am from Government Engineering College, Khagaria.
So, are you doing the assignments regularly?
Yes, sir.
So, are these live lectures helpful for you?
Yes, sir. Very good.
Do you have any suggestions to improve live sessions?
No, sir. I think your teaching style is very good.
So, you are watching the live recording sessions,
Mm,
recordings?
previously, all lecture learn from recorded.
Yes, yes. I have seen you today for the first time. That's it.
Yes, sir. This is my first lecture, sir. I also follow Sakshi Singh, sir, ma'am.
Yes, yes. And she is
Yeah,
all earlier last year. I think she was TA for the same course.
yeah.
Shall we start?
Yes, sir.
Let us begin.
Then
Yeah.
wait some student if will join 2 to 3 minutes.
Okay. Let us wait for 2 3 minutes. I will just. So tomorrow is the last date for submitting the assignment of week 6.
Yes, sir.
So have you completed?
No, sir. But yes, sir. Yes, sir. Approx 7, 8 question I have completed. 1 to 3 question I do not completed.
We can finish it by today after watching session or maybe by tomorrow morning.
Yes, I'll try to solve it.
Yes. Today we will be discussing the sag and tension.
Yes, sir.
And then the week 6, the second part is the radial load flow for distribution. Distribution load flow for radial distribution networks.
Yes, sir.
That we will cover in the next session.
Okay, sir.
So have you watched that video for load flow? should start now.
Yes, sir. Okay, start, sir.
Let us begin today's session, week 6 session for Power System Engineering NPTEL course. We'll be following the same agenda which we have been following for the previous sessions also. We'll just go through first half of this session. We will go through overview of week 6 and then we will discuss some questions. So tomorrow is the deadline for submitting the
Yeah.
assignment. You can submit. And the link is already available for the recorded sessions. Are you able to see the presentations which are uploaded on Google Drive?
Yes, sir. This is visible.
Okay, so let us begin at the week 6 overview. So in week 6, the main topic, it was continuation of the week 5. In week 5 also we discussed Corona, and then after that we discussed the sag and tension or transmission line. So it is applicable for both distribution and transmission line. Distribution lines also, they have this sag tension, but it is more important for transmission system, and that is why we are discussing here only for the transmission system. So in this, two methods for calculating sag and tension were discussed. One was a very detailed method based upon the actual curve of the sag. Say we have two towers, same height. Conductor will be something like this, and this distance between the two support or two towers is the span. And this curve represents the conductor, and the length of this curve is also the length of the conductor. Now it depends upon the span between the two conductors, what shape it will take.
Sir, please speak loudly. I think that your voice is so low, very low.
So is it better now?
Yes, sir.
Sorry for. So I was saying that this conductor between the two support, it has a particular curve, and if we take the exact curve, then it is called a catenary curve, or we call it in simple words a bow like. We have bow and arrow, so there is a string on bow, and bow is there similar to that bow. It is this curve for the conductor. And another method was the parabola method. It's an approximation of the catenary curve method, where the approximation is that this sag, let's say D or S, so this is very less in comparison to the span. So if it is very less, then the approximate shape is like parabola. So first of all, this detailed derivation was done for the category method, and then it was done for the parabola method. For parabola, the equations are very simple, and very few formulas need to be remembered. I think only one formula, two formulas, if you can remember, we can do all the problems for the parabola method. In category catenary curve method, there are a little more number of formulas, because also they are hyperbolic functions. Sin h or cos h terms are there because of the exact equation. So we'll see example for this parabola method as given in the assignments. Also almost all the questions are on parabola method. So it is easy to remember this formula also. And then this discussion was done for two different types of support levels. If two towers are of the same height, then this is the case as shown in the figure. But there are cases when the towers may not be of the same height. Suppose a river crossing or at the mountains. In mountainous region, the height of the transmission towers with respect to a common level, common ground is different. It is not same. And conductor is something like this. Shape is different. So this is the first case where symmetrical support level is there. This is the unsymmetrical support level. Here the both the heights are same. H1, H2. H1 is equals to H2 here. But here heights are different. There is a difference this much. This is the difference in height H. This is H1 and this is H2. So equation for parabola, this parabola method is y here is w x square by 2t, where t is tension at the support here. T is the tension and x is the distance. So this is the 0 point. And from here x is measured. So if you want to calculate this sag, so for calculating this, what should be the value of x here?
Zero.
If x is 0, y will become 0. Right, so y is equal to 0 is the point. So if you want to you get the value of sag, then here it will be L by 2. This one. This for x is equals to 0, y is 0. But if we take this value L by 2 on either side because it is symmetrical, then it will become WL square by 80. Is this clear? Pramod? Is this fine?
Yes, sir.
So this is the point na? 0 comma 0. X is 0, y is 0 here. If and what is the coordinate here? This is L by 2, capital L by 2, and sum this. This is S. This is the sag. So as we increase, this value will increase, and at this point we will get the maximum. That is why at x is equals to L by 2 half, it will become omega L square by 80. We can use the same formula for calculating the solving problems for unsymmetrical support levels also. In this case, what will happen? Suppose this is the minimum point. This is a total distance L span, and let us consider this is x and this is L minus x. Now we can use the same this equation. We have to use this equation. Now we have to use it two times. H will be, what will be H here? How will you calculate H?
L2 minus H1.
H2 minus H, right? Yes, correct. So H2 minus. So this is H. This total is H2, this is H1. And if we take, this is 0, 0. So y is 0, x is 0 here. Here, so this distance comes out to be H2 minus H, and which we can write. So what will be the equation now? So if we substitute this value, sorry, in this equation, x, we can substitute one time it is x, for the second one it will be h L minus x. W L minus x square by 2t minus W x square by 2t. So this will be h. W is known. We don't know x. T is known. If in the question all these things are known, then x can be found. So it will be a will it be a quadratic equation or linear? We can write this. We can take omega, so w by 2t common. It will be L square plus x square minus 2Lx minus x square. X square will cancel out. It becomes a linear equation. Minus 2Lx. The 2 also cancels out. So omega Lx by t. Okay. So if we know all these things, h is equals to minus omega Lx by t. So if one is unknown and others are known, we can calculate that value. So there is one question, and we will take one question for this. So is this clear, Prabhu?
why minus sir here? This minus sign what indicates?
So it will indicate that if comes out to be negative, then what will happen? That means this x which we have here, this is 0, right? We have considered this point is at 0 position. Let's say call this point is A, this is A, this is O, and this is B. Let me just draw and add one page here. I was saying this is point A, this is point B, and this is point O. O. And this is 0, 0. X, sorry. X is 0 and Y is also 0 here. So we are measuring everything with respect to this point. So this total distance is L, and this we are taking it as X. Positive X means point A is on the left side of point O. If X comes out to be negative, that means our assumption that point A is on the left side is incorrect. So for negative X, it will be something like this. This this O will be here. This is point A. This is point B. And this is, let's say, the middle. This distance is still L. And this is X. But actually, this value is negative. Now, this point P is at midpoint. Okay. This is L by 2. And this is also L by 2. Now, suppose I have this X value as minus 100 meters. Okay. And L is 200 meters. Now I want to find out the distance of point P from point O. So what will be the distance? Distance OP. What will be the distance?
So 200.
Yes. So how did you do that?
First of all, I divide L by 2 and then I added 100.
Yes. Because we want this distance. So it is sum of these two, AP and OA. Correct? And suppose the same thing we are doing here also. P is the midpoint. So this distance is L by 2. So AP is equals to PP is equals to 100 meters because L by 2. and x we already know x is 100. So in this case x is positive, here x is negative. So here what will be the distance between O and P?
X minus uh, yeah,
So you want this distance OP.
yes, sir. Ly2 minus x.
Yes, correct. So it will be L by 2 minus x. L by 2 is 100 and x is also 100. So that means both the point are same in this case. Same formula we can use here also, L by 2 minus x. But here what is happening? It is 100 and x is minus 100. That is why it becomes 200. Correct? So if x is negative, it will decide, it will indicate which side it lies with respect to the point O. Is this correct?
Yes, sir.
So this is very important. Whenever the question is given, don't assume that it is the same. Even if we do like this, so if we take the same convention, x will come out to be negative. So first of all, what you have to do, find out the value of x, the way we did here. So if everything is given, if h is given, w, l and t, everything is given, then we can easily find out the value of x. And if x comes out to be negative, we can shift to this case. Right? We can so make this diagram. If x is positive, use this one. So this is very important. We'll have one question on this where it will come out to be negative. It can be both positive or negative. If it is so, if it is negative, so accordingly we have to see. It's a very good question that you asked. So x can be, it can take three values. It can be 0, it can be positive, or it can be negative. Anything can happen. So when will the x value become 0?
When sag is 0 from one side of pole, I think.
That's correct. Um, because we are writing h as d1 minus d2 or d2 minus d1. So if a is like this, if O and A point are same, then x will become 0 and this will become entire L. So this is correct answer. one thing which was mentioned was the in case of unsymmetrical support, we have this because both the side we have different sag, right, and they will lead to different value of tension. That is why we calculate the ruling span or the equivalent span, so that we get a one value of span.
What is the means of ruling, sir?
So it is the equivalent span, or we can say rule. It's a rule which we can apply for both. Because here in both the case, this A and case B, case 1 and 2, in both the cases the span here on A side and B side, on both this, on either side of the tower is different. Here it is S1, here it is S2, and we know that sag is omega L squared by 8t or x square by 2t. So sag is dependent on tension also. So sag will determine tension also. So if we have different unsymmetrical, it will be different. Sag will be different always. So that will result in different tension at both the towers. And when you are using string insulators, if one conductor, there are two insulators on the either side. So this is the conductor. This is the conductor. Here also we have a string insulators, and this side also string insulators, and in between is the conductor which is hang on these insulators. So if tension on both the side is different, then it will result in oscillations. So that is why we calculate one value of tension on both the sides. That we can calculate by this. That we refer as equivalent span for both the sides or the ruling span. And using that we can calculate one tension value. Is this clear?
Yes, I understand it.
Yeah, so we are using this omega L square by 2 80. Here we have to use the equivalent length. So that there is one empirical formula for this, that L is L average plus 2 by 3 L max minus L average. So where L max will be the maximum of the two values and average will be average value. It will 1 by 2 plus L1 plus L2. So L1, L2 will be the individual span. So here it will be span of this one is x, here it is L minus x. So average here in this case will be x plus n minus x, which is same as L by 2. And maximum will depend upon the value of x. So here in this case it will be L by 2 plus 2 by 3. L max, it will depend upon the value of x, and this will also be L by 2. So L by 2 minus L by 3 plus 2 by 3 L max. This will become L by 6 plus 2 by 3 L. So if x is 0, L max will become, it will be same as L. It will depend upon value of x that we can calculate depending on the data which we have. Okay. So, that, shall we move to the next point?
How to calculate L max, sir?
L max we know if we know this value of x. Suppose x is 50 meters and L, the overall span is 200 meters. Then L1 will be x, which is 50 meters, and L2 is L minus x. So it is 150 meters, right? So maximum of these two value will be 150. So here it will become 2 by 3 into 150. And this is L is 200. This is 200 by 6. That's 600, 800 by 6. It will become 800 by 6, 400 by 133.33 meters. Okay.
Yes, sir. Done.
So let me add one more page. So next thing which we discussed was the effect of ice loading and wind on the conductor. Sag. What will happen to the sag because of ice loading as well as the wind pressure. So what will happen because of ice? If ice is there on the conductor,
Weight of conductor increases.
this weight of conductor. So if we have this conductor shape, then there is deposition of ice around the conductor. Then this additional weight of ice is added to the existing weight. So WC is the per unit weight of the conductor, and this additional is the per unit weight of the ice coating. We can add the two to get the overall weight, and then we can use this overall weight for calculating sag and sag. So there are, you can say, three cases. Can be. So this is when ice is there on the conductor. So this will simply increase the weight of the conductor, and then sag will be omega naught square by 80. So this is case 1. Now we have case 2. So first of all, how how are we going to calculate this value of Wi, weight I?
First of all, we calculate the area of ice.
How? What will be the area of ice? If this is T and this is thickness on both the sides, T. Let's say T is the thickness, D is the diameter of the conductor. So yes, how will we calculate? Because
Pi
we
by
want,
4.
yes, tell. So we want the weight of the shaded region. So we know two areas. First one is
Yes.
this out on the inner. Yes. What is the outer value of outer area?
Outer radius. Yes. pi by 4
and 4.
d plus 2t
Yes, correct. So d plus, sorry, d plus 2t square
square minus
minus
d square.
d square. Correct. So this is the area cross section for the ice. So this, if we calculate, then it will be d square plus 4t square plus 4dt minus d square. So d square cancels out. And 4 is also out. So it becomes pi d into d plus t. So if d is in centimeter, then we multiply it by 10 to the minus 4 to convert it into meter, meter square. Because this, the weight of the ice is given in this kg per meter cube. So you want everything in meter. Okay. If you multiply it with this value, let's say this is called rho density, then AI into rho I will be weight of ice per unit length. So it will be kg per meter. Okay, so this was the case 1. Now we have the case 2. 2 is for, suppose if now this is the conductor, diameter is T, and now the wind is acting. So wind can blow in any direction with respect to the conductor, but we consider that the weight of conductor is in downward direction. So this is WC. We consider the wind in which is perpendicular to this weight of conductor. But it will not always be perpendicular. It can be any other direction also. But because this will result in maximum sag, that is why we want to know this value. So you want to design the transmission line for the worst case. You cannot design the transmission line for, let's say, this wind direction, and if this wind flows perpendicular to the conductor, then this line is not designed for that wind direction, then it will create problems, especially for the vertical configuration of the transmission line. So that is why we want to calculate it for the worst case. So now it will become a resultant of these two, and the overall weight in this case will be some, let's say, omega naught dash, and this is theta. So this omega naught dash will result into a overall sag, and if we want the vertical sag, then this is a triangle. Here this is omega naught dash, this is omega c. So, so vertical sag will be s into cos theta. The sag will be like this, and we want its vertical component, then we can take cos theta, and we will get this vertical sag. And cos theta is equals to, so what is cos theta here? It is WC by W0 dash, right? Correct?
Yes, sir.
Yes. So in this case, the effective area, the projected area which the wind is seeing, it is only this diameter of the conductor. So these are two independent cases. One is only ice is there, only ice coating, then only wind is blowing, and third can be, and both are happening together. So in this case, this is a conductor, and we have ice coating. This T diameter, and so we have thickness T. So effective thickness will become D plus 2T. So if we take a rectangular with width as 1 meter and height as D plus 2T. So here the width was 1 meter and height was D meters. Here it becomes D plus 2T because of the ice coating. Now it is same. Now this is wind. Now this factor will increase. It is no more WC, it is WC plus WI. And the overall weight will become this. It is W2, it's a double dash. Which is, so here W dash was W W square plus W C square conductor. And here it will be wind plus, no, sorry, it is WC plus WI square. Okay, correct.
Yes.
So now we can calculate everything. We can calculate the sag now. We can use this well. So whenever in question, ultimate tensile strength is given, because whatever the value of tension is there for which we always design conductor for higher tension. Everything we design, we always take a safety margin. So whenever conductor is there, it is carrying current. So there is a thermal limit to it, how much current it can carry. Otherwise, if it carries a very high amount of current, then it can melt because of the heating losses. There is a thermal limit which will determine the maximum amount of current the conductor can carry. So we always have a safety factor. Let us say the thermal limit is 150 150 amperes. So actual current which we will allow, it may be, it will always be less than that. So there can be a safety factor of 1.5 to 2.5 depending upon the reliability level that we desire. So if it is 1.5, if it is 2, then we can allow only a maximum current of 75 ampere of current, continuous current. For momentary, it can, for some few moments, it can go to 150. So that is called, that is also another rating. So for different time period, we have different ratings, current ratings, even voltage. So these are considering the safety factors. So similarly here also for tension, we have a safety factor. That is why whenever in the question it is given ultimate tensile strength with the factor with a safety factor, some safety factor. So actual working tension will always be less than this ultimate tensile strength. So it will be this ultimate tensile strength divided by that safety factor. Okay. So
Hello, sir.
yes. So,
What is ultimate tensile strength means?
so this is the most of the time the tension for which it is designed. The conductor is designed as this tension, and we calculate the sag for that tension only. But for some reason, for any reason, the tension may go beyond that value. Not always, but sometimes it may go. So if our conductor is designed only for this maximum value of tension for which we have calculated this sag, if tension goes beyond that because it is only designed to handle this value, then it will break. But we don't want that. If for few moments, few seconds, tension goes beyond a particular value, the conductor breaks. To prevent such situations, so it's to ensure reliability. In any kind of system, we always have a safety factor. So to avoid such kind of situations, we always keep this safety factor so that for few moments or few instances, if tension even crosses this maximum design point, the conductor will not break. It will still work. It will be able to handle those stresses. Is it fine?
Yes, sir, done.
Yeah. So that is why everywhere it is not just for tension, it is for any kind of design. We always keep a safety margin because the system can always, it is always prone to some kind of disturbance. If there is some disturbance which result into very high value per moment, then system should still be able to come out to its original state. It is it's effect of wind highest location of line. So it was a very small point only. It depends upon right of way, mm, where we want to suppose generation is increasing. We want to build a new renewable plant somewhere, or on, or load in certain area is increasing, or both may increase. Then to evacuate power from that increase, new solar farm or wind farm, or to supply power to the new load, we may require new transmission lines, or we always plan for future. We don't know how much load will be there, but we plan for next 10, 15 years. CEA has come up with the 2030 transmission expansion plan. So for next 10 years, we are planning for requirement of the expansion of transmission. So depending upon the projections, forecasted load on expected generation, we carry out some study and find out that these are the possible. Even before doing that, we have to find out where can we build the transmission line because it requires land. Tower needs to be erected, and both side of suppose here we have tower. This we have towers. On both sides of the tower, some space is always kept. So this overall space is called a right of way. ROW, right of way. So we may not be able to erect transmission line at any location. We need to find out the places where we can reduce the cost. We can get the minimum cost. The cost of construction, cost of land acquisition, and cost of maintenance, and all these things are considered while deciding that this will be the route of transmission line. Land acquisition is a very big problem, and it requires a lot of right of way to be cleared. If some land, agricultural land is there, then it becomes difficult. So, first of all, that feasibility study is done considering the minimal cost. And once we have, let's say we have 10 ROWs that we have identified, and considering these, the study is carried out.
What is
Out of
ROWS, sir?
it is right of way, ROW
Right of
way. So this
wind.
total, this this area which is required to be clear. So the entire transmission corridor will be having this both sides.
पढ़ा नहीं उसमें पढ़ा
So after that, this one was this Sag template. So using this, we can calculate design of Sag. It can provide us economic layout and proper grading of structures, and also minimize the error in design and layout. There is one also stringing chart. Using that, we can calculate value of sag and tension at any given temperature. Because depending upon temperature, sag varies with temperature, right? What will happen if temperature increases? Will sag increase or
Sag
it
will
will?
be increased.
Yes. So this chart can be used to calculate these values. Because we need to design the line and it has to withstand all the seasons. Considering all those different temperature conditions, we need to design the transmission line beforehand. All these things are taken care before taking the final decision. Then this was last one. This is Aeolian vibration and galloping. So, do you remember about what is this?
No, sir.
These these are also called resonant. This happens because of wind speed, also called as. This happens at low wind speeds. swings here are large. And these.
Your writing is not clear, sir. Very cursive like.
Is this clear? This fine?
Yes, sir.
First one is this Aeolian vibration. It is also called resonant.
Voice is also low, sir. Please speak loudly.
So first one is Aeolian vibration, and it is also called resonant vibration. These have very low amplitudes. These vibrations are very small. Very. I don't know whether you have seen or not. But on conductors, there are some structures like this. Especially near the point where near the support. So, little distance away from the support. On each conductor, you can see a structure like this. Have you seen? Very small. So, it's like some rectangle, not like exactly rectangular, like this. And this is the actually conductor is here above them, and they are below, like this. So they help them to reduce. So they also add to the weight. Because on both the side of the support we have these dampers. These are called dampers. So which dampers means they damp the oscillations. So they are very small amplitude oscillations and which are reduced by these dampers. That's why we apply them. Because they are very small, we are able to use these. And these are because of very low wind speeds. And because wind is always there, little bit, and these wind can create this problem. So that is why we have this most of the time. And since we have them most of the time, we want to avoid them and we use these dampers. Next time when you go out and you see some transmission line, you can observe this. Near the support, maybe 1 or 2 meters away from the support, you will find on the both side of the conductor, on both tower, you'll find such dampers in each face. You can next time when you see any transmission line, just try to observe it. Okay. These are also low amplitude, very small vibrations. But these are large. Their amplitude is more, but frequency is small. Their amplitude is large. And this is generally because of asymmetrical ice formation. And just to avoid these ice formations, and recently one company has launched one drone-based tool, so that drone goes over the transmission line, and it is very controlled. So it has one string, not a structure which is hanging from the drone. It will swing it, and it will just touch the transmission line conductor. So if we have three conductors, so here some drone is there, and there is one hanging structure. So it will just swinging, it will touch and remove all the ice for each of the conductors. So this we are able to reduce. By this we are able to reduce sag also, and this phenomena also. It is very helpful. It's a very new concept. So I have that video. I will share the link with you. You can
So
watch.
galloping is also a vibration.
Yes, it. So yes, vibrations in the conductor.
Means alien vibration is also called hissing noise.
No, no, hissing noise. That is hissing noise is because of corona, right?
Yes.
So
But what is the reason of this alien vibration?
it is because of this low wind speeds.
Means
Exact.
collision of wind with a transmission line.
Yes. So because of which it's in fluid dynamics. There is one concept. This phenomenon, vortex. I don't know in detail about this, but this causes these resonant vibrations.
Okay, sir.
But it's almost a constant phenomenon. We need to avoid it by using these dampers. So ice formation, this is limited to the places where we have snowfalls. Really, in India we have Himalayas. At other places we won't find this. So I saw that video. This I think that tool is being used in Europe. Okay. So now let us start with
What?
questions. Yes.
1 minute break, sir. I go to toilet.
Okay. Sure. Sure. You can meet.
Start, sir.
Okay. Now we'll see questions. I think this is already discussed. So first question is temperature increase produces the following effect on a transmission line. So you already answered this. What will happen to sag?
Yes, sir. Sag increases and tension decreases.
Yes, because we know that sag is omega x square by omega L square. So they are inversely proportional. So if sag increases, tension will decrease. So this is correct. Good. So this also I mentioned. I mentioned that stringing chart is helpful in knowing which one is correct.
D.
D is correct. So we can know both sag and tension at any given temperature. Now this is first numerical, very easy question. So it is given that span length is 2L. Horizontal tension at support is T by 2. Weight of the conductor per unit length is W. So what is the maximum value of sag? So try to calculate.
Yes, I. 1 second.
Yes,
W,
we just have to.
8. Their answer is B, correct.
Yes, correct. So it is. It's a. We call it omega L dash square by 8T dash. So here omega dash is omega, L square is 2L square, 8T dash is T by 2. So it is correct. Omega L square by T. Next is this. The sag of the conductor of a transmission line is 3 meters. So sag is 3 meter at a span length of 200. When the span length is 200, sag is 3 meters. If the height of the supporting towers is increased by 20%, the sag will be. So what will
Sag
happen?
will be sag will be remain same because there
Yes,
is no effect of height.
correct. So sag we already know. It is there is no height dependency for sag. It is dependent on the tension and weight of the conductor, and also on the span length. So it will remain. Which option is correct then? Out of these,
Option third.
yes. So it will be 3 meter only. Correct. So now the questions will become. Now it will all the gradually questions will be difficult. Now this you will have to do some calculations. Now all the subsequent questions will have to calculate.
Yes.
So this question is, first of all, you have to calculate sag. Okay, sag for a span. So span is given. Span capital L is 250 meters. Okay. Ultimate tensile strength. Yes, we discussed this. This is it is ultimate tensile strength is 6250 kg. And safety factor is 2. So what will be tension? Working tension.
Tension will be 6250 by 2.
Correct. So tension is 6 tensiles ultimate tensile strength divided by 2. So it is 3125 kg. Now next thing which is given is the weight of the conductor. So weight of the conductor W is 800 kg per kilometer. But we want everything in meters. So how much will be this weight in meters? Kg per meter.
0.8.
Yes. It is 0.8 kg per meter. Now everything is given. We know the value of formula for sag. So calculate what will be the value.
Value option A is right.
Oh, 2 meters.
Yes.
Yes. It will be S is omega L square by 8t. Where omega is point so 250 250 is 2 meters. Next question is 132 kV lines, 50 Hz transmission line has the following data. weight is given, so it is 0.75 kg per meter. Span is given, which is 250 meters. Ultimate tensile strength is 3600, so tension will be divided by 2, 1800. We have to calculate the approximate height above the ground at which the conductor should be supported, and minimum ground clearance is 12 meter. So if nothing is given, that means both the towers are at the same height, and so this is the ground. This value is given. This height. This is 12 meter, and we want to find out this h. So what will be h? H will be, so how much is sag here?
2.6 approx.
So 2.6. 2.6 is not correct. Check once again.
18, 18, 75. Oh, एक second. 1 second, sir. No, sir. 3.25.
Yes, correct. It is 3.25 meter. So if we, so this is sag, right? And ground
Yes.
clearance is 12 meters. So height will be sum of the two. So height will be 12 plus. So which option is correct?
C.
Yes. So C option is correct. And this is the next question. This is considering the wind pressure. Span length is given as 200 meters. Conductor diameter is given as 15 mm. So this is 1.5 centimeter. Tension will be, safety factor is 3. And weight of conductor is given as 0.85 kg per meter. Wind pressure is given, so P 60 kg per meter, should be meter cube, projected area. Sorry. This is meter square. So what is weight for wind? Weight. Horizontal force for wind per unit length. How much will be this? This will be P into
P into sin theta, horizontal.
So what we are doing here is, this is conductor, right? And its thickness is D, correct?
Yes.
So force of wind is in this direction. Wind is exerting a force. This is the weight of the conductor, perpendicular to the conductor. And the wind is blowing, the pressure which wind is producing is this 60 kg per meter square. So if we take 1 meter of width, 1 meter length of conductor, and diameter is, you already know. Let's say this is the conductor. Okay. This is the weight of the conductor, and this is the wind pressure. Let's say P. So we can say this. So this is 1 meter, and this is D, right? Diameter of conductor. So it becomes a rectangle, and it is, since 1 meter, and we want in per unit length. So we just have to multiply it by D, the diameter. So the effective area per unit length which the wind is encountering is only the diameter of
T.
conductor. Correct? So how much will be this? P into
T.
P into D. So how much is this? 60 kg per meter square into D. How much is D? Yes, D is 15, 1.5 centimeter. We'll convert it into meter. So how much is this? What is the value? Product. How much is WW? Did you calculate value of sag? No? This is 0.9 kg per meter, right? So how much is W, not effective weight per unit length? How much are you getting? Am I audible? How much?
Yes, sir. 1.237.
Yes, correct. So, and what is cos theta? Value of cos theta?
0.9 by 1.237.
Why 0.9?
No, zero point 0.9, no sir. 0.85
Yes,
because this is base.
right. 0.85 divided by 1.237. So now, first of all, we have to calculate the overall sag. Calculate this value first. Omega not L square by 80. What is this value? First calculate this. How much are you getting? This. How much is this?
One second, sir. I calculate it.
Yes. Calculate.
4.1.
Yes. But so this is overall sag. But here it is asked you have to calculate the vertical maximum vertical sag. So what will be that? So this component will provide. So it will be S cos theta. So what is this? Vertical sag. How much is this? Cos theta we have already calculated. This comes out to be which option is correct?
I calculate it, sir. Option A is correct.
So how much are you getting? What's the value? 2 point.
Value is 8 point, no, 2.835.
Yes, correct. It is 2.83 meters. Correct. Yes. Option A is correct. So now next question. Now this is a very interesting question. The point which we were discussing earlier, and there is a asymmetrical support. What happens if the value of x is negative? So in this question it will happen. So let us do this question. We will do it very slowly. It's a good question. So question is a transmission line near. This should not be line. This should be river. River crossing is supported by two towers of height 40 meter and 80 meter. So there are two towers. So one is at 80 meters and one is at 40 meters. Let's say this is 80 meters and this is 40 meters and this is the river crossing. And horizontal distance between the two towers is given as 200 meters. This is 200 meters. If the tension of the conductor, it is also given. So tension is 1500 kg. Find the clearance in meter between the conductor and the water level at the point midway. So let us assume this is the midpoint. We want to calculate this D. Let's say D mid. This is L by 2 and this is also L by 2. And weight of the conductor is 0.9 kg per meter. So it is already given that we have to assume the parabolic shape. Now just by seeing the data we cannot say whether x here will be positive or negative. So let us assume this is at point of minimum. This let's say this is the minimum point, and we'll designate this distance as x and this is L minus x. So now we have to calculate the value of x. So can you calculate value of x? What do we have to use? We have to use this, the basic equation for, let's say, this point O, this is point B, this is point A, and this is point B. Okay. So for these two segments, span length is x and L minus x. Now substitute these two values here and calculate their individual spans. And we know that the difference between their span is this, which is 80 minus 40. So 40. This diagram is not to scale because this is 40 but this is not appearing 40. So we are saying 40. 80 minus 40 is equals to, what should I write here? Omega W into, what should come here? L minus x or x?
I don't know, sir.
So let's just see. We are trying to take difference between two spans, right?
Yes.
So here we also know that this is y. Right? This is equation side. This is not s. This should be y. So y is given by this equation, right? Now we have two different span lengths. So x is that value. One is x, one is L minus x. And we know the value of y for both of them. For this part, from part OA length of conductor, y value is 40 meters. And for OB, it is 80 meters. Correct?
One question, sir.
Yes.
There is a difference between 40 meter point and ground level to OP point.
40 meter point.
Means A and dotted line do not touch to point P. Then how O to P value is 40 meter?
No, no, O2P is not 40. See, 40 is this from ground. So this is ground, right? The formula which we are using this this considers that the minimum point is at 0 comma 0. Correct? This we
Yes,
have done, right? Do you remember?
yes,
Yes. So now we already know. No, we don't know this value. We also don't know how much is this from this point to this point. We don't know, right? We don't know.
yes,
We only know this distance from ground. That is correct, what you have said. But we know the difference between the two.
yes,
Correct?
yes.
We know the difference between point A and point B. So we are
Maybe
using
40
this
meter, yes.
difference value. We are not saying that this this height is 40. We are only considering the difference between the two because we know the value of difference. So this difference we know, and we also know them in terms of the formula. Correct?
Yes,
So now I am saying that difference between this one y of b, y value for b point and y value for a point, this is equals to 40. So now how can I write this y value for b in terms of using this equation? What will be x for b point? Now can you tell? For this point b, what will be span for this x value?
2000 minus x. 200 minus x, sorry.
Correct. So we write L minus x. Okay. 200 minus x, that is correct. And what will be this? Ya W into
X square.
correct. So this will be x square. Now what we can do? 40 2t by omega we can multiply here. This becomes L square plus x square minus 2lx minus x square. L square we know it is. This is 2lx is equals to L square is 200 minus 40 into 2 into tension is 1500 and weight is 59. Now calculate this value. This is also not. This is L is 200 into x. So now calculate how much are you getting. This will be 100 minus impedance. So 40 into 300 into this is 5. This is 300 by 0.9. 100 minus 300 by 0.9. How much is this?
56.5 minus.
Calculate it once again. There is some error in calculation. Do it once again.
Minus 566.
No. Let's do this. 100 minus 300 by 0.9. What is this? Calculate this.
Oh, 0.9. Oh, sorry.
How much did you take this earlier?
Yes.
Sorry, I think it was not visible as 0.9. This is 0.9.
Minus 233.3.
That's correct. So now x value is negative. So what does this indicate?
Our assumption is wrong that this is live from here origin.
So now what should we do? So what assumption is incorrect?
Our point is from means here 0 point is not right.
Yeah, so it should be here, right?
Yes.
Right. So point A should be on same side as point B with respect to the point O. Let me add one page. So our assumption was not correct.
Yes, sir. Your battery is low.
Okay. So it should be like this. This is point B, this is point O, this is point A, and we want to find out, we are concerned with this midpoint. Now This distance is 200, already given as L is 200. This distance we know because this is midpoint, so this is how much? This is 100. This is also 100. And this is x, which is 233.33 meters. So how much is this distance OP? And OB. So this is DP and DP. This is DP from this is from here. Similarly DP and D. So how much is this? OP and OB distance? Correct. You can also calculate it like this: L by 2 minus x. So it is 100 minus x is minus 233.33. So it is same as 330. Similarly, OB will be L minus x, which is 100 minus 200. Which is 433.3. What are we supposed to calculate? Clearance between the conductor
Yes.
and water level at midpoint. So we want to calculate this value of dP, the distance of this point P from the ground. So Pramod, can you tell how to calculate this value dP? What should we do?
PP. You have no ideas.
Whatever, only one formula we have. The way we calculated the value of x, same we can use, right? But now we know the value of x. What did we do earlier for calculating the value of x? What we were doing, we did dB minus dA, and then we used the formula of yb minus ya. Correct? Here we knew both the values, dB and dA. But if we apply the same formula here for dB and dP, here we know dB but we don't know dP. But we know this yb and yp in terms of x, because we know the value of x. So what will be this? This is omega by 2t we can take common. And this will be, how much will be x for point B from this point O? How far is B? Yes. Whenever we are using this formula, no, y is equals to omega x pi by 2, all the distances are to be used from this point O. So can you tell for both these point P and B what will be this x with respect to point O? We have already calculated. So in this equation everything is known, only one dp is unknown. You just have to tell me what are those known values. This is already known. This side is clear. What should I write here for point B and P? You can take hint from here. This is YB and YA. So for point B, distance from point A to point B is L minus x. And for from O to A is x. That's why I'm writing here for B L minus x and x for A. Correct? So now can you tell what should be the value of x here for point B and P?
I'm not visualizing this at that time. At this time,
You just have to tell me what is the distance between point O and point B.
433.33.
Yes. So see, here we did the same thing. YB minus YA. YB is omega xb square by 2t. And xb here is L minus x, which distance between point O and point B on the x-axis. Similarly, distance between point O and A is x. Correct? Is this fine?
Yes,
Similarly, so what will be xp here? Xp, this will be xp square minus xp square. So what will be xp here? The distance of point O from point P from point
the
O. How much?
200.
This distance
OP.
between O and P.
Yes, yes, 433.33.
Hmm. This distance and this distance, these two are different.
Yes, sir.
So which one? How much is this OP?
OB is 200. Yes, sir. 433.33 OB.
No, OB is for 3. Correct. OP?
OP 333.33.
Yes, correct. So XB will be this one, right? 433, correct?
Yes.
So weight, how much is weight? 0.9 by 2. How much is this? 1500. 233.33. So now, can you calculate? How much are you getting? 80 minus this value will be value of dp. Calculate this one. How much are you getting? This is 80 minus 0.9
Yes.
divided by 2 and 1500.
57.
57?
Yes.
Correct. I think this answer is correct. Yes. 57 is correct. Good. Done. So, now two more questions. These are very simple questions. So, an overhead transmission line conductor has span is given as 250 meters. And this is L. And so safety tension is 2500, 5000 divided by 2. If sag is 3 meter, sag is given as 3 meter. What is the weight of conductor? Very easy question. Yeah? What will be the weight? Calculate.
Yes, I calculate it.
Yes.
0.96.
But there is, so what is the unit?
This
0.96?
unit is kg per meter
Yes.
square.
But we want weight in kg.
Kg.
So
We will
how?
multiply by 1000
Why 1000?
because
We
no.
want to multiply it by the length of the conductor.
Yes.
So we need to find out the length of the conductor. So what will be the length of the conductor?
Mm,
There is one formula for this. This is
yes,
the
sir.
formula. So this is the formula. 8 into 1 plus 8. This is s square by 3 capital L square. So using this we can find out. So it is this 250.096 meter. So if you multiply it, we will get 240.092. Is this fine?
Yes, sir.
Yeah, so this question is also good. We can remember this formula also. So for parabolic, you have to remember one formula is this 2t. And when x is equals to L by 2, you will get omega L square by 8t. And one you can remember this one, length. These two formulas. Last question. So transmission conductor having a diameter of 20 meters, so 2 centimeter, 20 millimeter, and weight of conductor is 0.82 kg per meter. This span is given as 250 meters. Wind pressure is given 42 kg per meter square. And ice coating T is 1.5 millimeter. 1.5 centimeter, 15 millimeter. And tension is 35 mm. Weight of ice is 910 kg per meter. So here ice and wind both are there. So we need to first find out W wind and W ice. How much will be these two values? Calculate. This will be rho I into D plus 2T. Correct? And in, because these values are in centimeter, right? How much is this?
Hello.
Yes.
209.3.
Which one?
WW.
20.
9.3.
This is very high value. This it should be small value. Check once again. Sorry, this mistake. This is not. This should be wind pressure. No?
31.85.
This calculate this.
Yes.
Calculate these two values. This will be W wind and W ice. This is 42 into 2 plus 2 into 1.5. How much is this?
0.21.
No. Are you sure? 42 into 5 into 10 is power minus 2. Check once again. 0.21 or 2.1.
6. 1.89.
Hmm.
3. 5.5.
So this is 5. No? 2 into 1.5, 3 plus 2, 5.
2.31. 2.31.
42 into 5. How much is that? 42 into 5.
2.1.
Yes. So this is 2.1. So 42 into 5 is 210. Into 10 is power minus 2 is 2.1. Correct?
Yes.
Now calculate this one for ice coating. So it will be pi into rho I here is 910 into T. T is 1.5. D is 2 plus 1.5 into 10 to the power minus 4. How much is this?
1.5.
Correct. This is correct. So now we have to calculate effective weight. This will be WC plus WI square plus WW square. How much is this? WC is zero point 0.8, WI is 1.5. So calculate this one. This is 2.1.
3.11.
Correct. So now what is maximum strength, maximum sag. So this we can directly calculate omega naught L square by 80. So how much is this? Calculate.
6.94.
In these options I have, these options are incorrect. I didn't change them. This is the correct one. 6.9495. This is the correct option. This is correct. D. All the questions are done. So do you have any other doubt? No?
No, sir, I have no other doubt.
So thank you very much for joining and patiently attending the entire
Sir,
session.
I want to one question.
Yes.
After the completion of this subject, if I have any doubt from previous assignment, then I can ask you.
After the completion of means which is this entire course?
Yes,
Uh,
madam, means I want to ask a previous assignment related any problem.
yes,
Then
yes,
how
you can ask.
in this slide, if any day,
Yes, you can ask.
how to ask, sir, if I have any doubt.
What you can do, one thing is either if you're able to attend session, then in session you can ask. Otherwise, what you can do, you can the videos which are uploaded, you can write uh, reply on that,
Yes,
or you can ask in discussion forum also. Just mention that video.
sir.
Otherwise,
Next live session, when will we going?
next will be Saturday 3 to 5. Are you
Okay, sir.
available on
Thank you, sir.
Saturday 3 to 5?
Yes, sir. Saturday I am free.
Okay, so you can attend 3 to 5 and there you can ask whatever doubts you have from previous assignment. Any doubt?
Okay, sir. If I have any doubt, I can ask.
Yeah, sure.
I ask you.
Okay. Thank you, Pramod.
Thank you, sir.